So, if you want to calculate your acceleration, the formula used is change in velocity over time, which is A equals V minus U over T, where V is final velocity and U is initial velocity. Question 2, list different units used to describe acceleration. You might use meters per second, or you might use kilometers per hour per second. Those would probably be the most common ones that we'll use. State what is represented by the gradient of a velocity versus time graph. We spoke about this before. The gradient tells you the acceleration, because essentially a velocity versus time graph is showing you some type of change in velocity over change in time. 5. Although acceleration due to gravity is 9.8 meters per second squared in practice, an object dropped from a height on Earth, such as a ball dropped from a tree, will not accelerate rapidly. Explain why. Can anyone give me a reason why? Yep. Good guess, but no. Yeah, it's everything to do with air resistance. So they wanted you to consider air resistance acting on an object when it falls. So for example, if you had a feather and you dropped it from the top of a tree, that thing's not going to drop very quick, is it? No, because air resistance is acting on it. But if you had something really dense, like a bowling ball, and you drop that from the tree, would that accelerate quickly? Yes. Yeah. It's because not as much air resistance will be, or the effects of air resistance won't be as noticeable on the bowling ball as they are on the feather. So for 5, you should have said, because air resistance affects the rate at which the object accelerates. Right, you didn't have to do 6. Question 7. Explain the difference in motion between a train travelling at 8 meters per second squared and another travelling at negative 8 meters per second squared. Patrick? Good. This one here, 8 meters per second squared, is accelerating. This one here is decelerating. Alright, now, this is the one that I reckon people might have got stumped on, but I'm not sure. So, a toy truck was stationary, then rolls down a long ramp with a constant acceleration of 0.2 meters per second squared. Calculate its speed after 1 second, 2 seconds, 3 seconds, and 10 seconds. Now, after 1 second would probably be pretty easy to work out. 2 seconds, maybe a little more difficult. 3 seconds, more difficult. Now, remember how we used, I gave you a couple of equations the other day that you could use. Did anyone try and apply this one? Did anyone try and apply V equals U plus AT? Alright, because for A, 1 second, so our T is 1, our acceleration is 0.2 meters per second squared, and what would its initial velocity be? 0. So do we have all of the information that we can put in here? So for A, 1 second, we would know that V is equal to our initial velocity 0 plus our acceleration was what? 0.2 meters per second squared times 1 second. So it will be 0.2 times 1, which is 0.2 meters per second. Alright, and then part B, after 2 seconds, V will be equal to, our initial velocity was still 0, starts at rest, plus 0.2 times 2, and 0.2 times 2 is equal to 0.4 meters per second. Alright, so you could have done it in your head, but in a test this would be a very clear way to show how you're determining what you're getting. So C, how many seconds did C ask for? 3 seconds. So V would be equal to 0 plus 0.2 times 3. 0.2 times 3 is 0.6 meters per second. and then D was 10 seconds. So D, 10 seconds. V is equal to 0 plus 0.2 times 10. 0.2 times 10 is just 2 meters per second. Alright, is that what people got? Cool. Alright, so just so you know, that's the formula that I was using. That's one of the ones that we were applying yesterday. Alright, then 9 required you to use a table from a different page. So to calculate the average acceleration of a car as it accelerates to 100 kilometers per hour in the time stated, express your answer in kilometers per hour per second and round off to one decimal place. So here's the table. Now I'm not going to do all of them. I'm only going to do the Volkswagen Golf GTI because that's the car I've got. So let's have a look. You have to work out the acceleration as it accelerates to 100 kilometers per hour. So what would be its initial velocity? 0, and it accelerates to 100 kilometers per hour. So see that we've got the change in velocity, and then this table told me the time that it did it in, 7.3 seconds. So therefore we can work out the acceleration in kilometers per hour per second. So let's have a look. This is question 9. Acceleration equals change in velocity over change in time, which is v minus u over t. The final velocity that they wanted to get to was 100 kilometers per hour, minus the initial velocity was 0, over, this is for the Golf, it was 7.3 seconds, and so the speed was in kilometers per hour, the time is in seconds, so see how it's going to be in those units that they said, kilometers per hour per second, so we don't have to do any conversions there, we just have to go 100 divided by 7.3, and how many decimal places did they want it to? Just 1, so the comes out as 13.6986, so to 1 decimal place we have to round the 6 up to a 7, so it'll be 13.7 kilometers per hour per second. So each second it accelerates by a rate of 13.7 kilometers per hour. Did anyone do it for the Nissan GTR? What was that for comparison? The acceleration of that one? 28.6 kilometers per hour per second. Alright, so quite a big difference. Alright. 10. So we want to work out. So John accelerated to a speed of 1,017 kilometers per hour in 5 seconds and then came to a stop in 1 second. Convert this speed into meters per second and then calculate his average acceleration in reaching 1,017 kilometers per hour and the deceleration in coming to a stop. Alright, so the first thing that we're going to do is do the conversion. So we want to convert this into meters per second. So from going from kilometers per hour into meters per second, we said that we divide by 3.6. So this was question 10. I'll start off by saying velocity equals, what was the initial? 1,017 kilometers per hour, which is equal to 1,017 divided by 3.6 meters per second. Did someone do that division already for me? 282. 82.5 meters per second. So now we've got our velocity in meters per second, and they want us to work out the average acceleration, and he did that acceleration in 5 seconds. So it's the same thing. Acceleration equals change in velocity over change in time. So he went from 0 to 282.5, so 282.5 minus 0 over, what was the time they did it in? 5 seconds. So you get 56.5 meters per second squared. And notice that it comes out as a positive value because he's accelerating. Then the second bit, he comes to a halt, and he does that in 1 second. So he goes from that speed to 0 in 1 second. So therefore we're just going to go, so this was part A, part B. Same thing, acceleration is still equal to change in velocity over change in time. But this time his final velocity is 0. So you're going to have 0 minus the speed that he was at, 282.5, over, how long did it take him to come to a halt? 1 second. So it's going to be negative 282.5 meters per second squared. I think we have one more. This motion graph. So describe the motion over the 12 seconds shown on the graph. You would say the leaf begins moving at 12 meters per second. It decelerates for 6 seconds until it is at rest. It then accelerates for 2 seconds, where then it moves at a constant speed of 6 meters per second for 6 seconds. That would be the type of analysis that you'd be doing on that graph. Is it? Oh, sorry, 4 seconds from 8 to 12. Thank you. B, calculate the acceleration of a leaf in the first 6 seconds. I'm not going to do this, but if you wanted to do it, you just find the slope of this line here. Actually, can I do it in my head? Change in y is 12, and change in x is 6. 12 over 6 is 2. So the acceleration you should have got was 2 meters per second squared. That's in the first 6 seconds. Negative. And that's indicated by the negative slope. Therefore, it's a deceleration. C, the distance traveled in that time. We've got a triangle. You have to go base times height divided by 2. So 12 times 6 is 72, divided by 2 is 36. So you should get 36 meters. And D, calculate its acceleration between 6 and 8 seconds. So that's that bit there. Again, you'd just be working out the slope of the graph in that area. Do you have a question? No? All right. We will leave that there.